Durability also a measure of product life, and so on. And then classifying customer requirements. There are four level of customer requirements, which is the expectors, spokens, unspokens, exciters. Okay, so we need, in order to meet the requirements, right, we need to know where our customer is belong to. All right, so like in expectors, there are the basic attributes that one will expect to see in the product. Okay, expectors easier to measure and are used often in benchmarking. Okay, so here it is located here, expector, which is must have. All right, it has in this region low satisfaction but fully implemented. All right, and spokens, these are the specific features that customers say they want it. All right, okay, so these are the requirements, that what are the spoken requirements, customer requirement, which is the customer say they want it in the product. Okay, number 2. All right, more focusing on the performance. All right, the requirements, the first requirement, which is the basic requirements, must have, the product must have. If the product doesn't have that features, the product does not perform. But number 2, there are specific features. If that features doesn't have in the product, still can perform, but not according to what customer wants lah. So the designer must be willing to provide them to satisfy the customer. So fully implemented and high satisfaction given to the customer. Customer feel delight to have that kind of product. And then unspoken, which is in number 3, which is these are product attributes the customer does not generally talk about, but they remain important to customer and cannot be ignored. Alright, and lies under this region. And then customer may either simply forgot to mention or does not realize what they want. Right, this is unspoken requirements. It requires great skill for the design team to identify, and also will be added advantage to design team if they can identify these requirements. Okay, and exciters, these are product features that make the product unique and distinguish it from the competition, which is indifferent under this region. Alright, so these are 4 types of requirements, customer requirements, that we can look upon when considering to design the product. Alright, so that's for the customer requirements parts only. Moving to the engineering characteristics. Alright, where these engineering characteristics need to be engaged with the customer requirements. Alright, from the customer requirements, how we can match with the engineering characteristics. From the customer requirements, we want to have a relationship with the EC. How? Alright, so under this establishing the engineering characteristic, okay, we will be discuss on the benchmarking, competitive performance benchmarking, reverse engineering or product dissection, determining engineering characteristics. So, okay, so alright. So what are the set of engineering characteristics? So there are 3 main, right, terms, or 3 main items under this set of engineering characteristics, which is design parameters, design variable, right, and then constraints. Okay. So design parameters involve a set of physical properties whose values determine the form and behavior of a design, where the features of a design that can be set by designer and the values used to describe the performance of a design. Okay, so which is something that you can change, you can modify. right? Like surface area, a volume, right? The length, right? Some things like this design parameters, which is that you can design, right? Which is the physical part. I would say the physical aspect, yeah, physical aspect of the products. And then the design variable, which is a parameter over which the design team has a choice, right? Like the um, mass, right? The weight of the product, like um, I would say the speed, right? And also the constraint are limits on the design freedom. Constraint may be limits on the maximum or minimum, alright? So each parameter would have the minimum and maximum value. That is the constraint. Alright, the constraint of your design. Okay, maybe you cannot the design of the product cannot withstand certain amount of force. So that from that limit you may know what types of material which is suitable for the product that can withstand certain amount of forces, all right. Okay, so in order to establish the engineering characteristics, first what we need to do is the benchmarking in general. Okay, what are the common source of resistance to benchmarking, which means what hinders the benchmarking from going on? What are the factors that limited the benchmarking exercise, right? Fear of being perceived as copiers, fears of yielding competitive advantage, arrogance, impatience. So that leads to the resistance to benchmarking. Okay, we don't want we are not willing, the organization not willing to compare, all right, to see the weakness of the own organization with when compared with other organizations. And there are two main steps of benchmarking process. Select the product, process, or functional area of the company that is to be benchmarked, which is to influence the selection of key performance metrics that will be measured and used for comparison, and then identify the best in class companies for each process to be benchmarked. Okay, we look higher. All right, we benchmark with the best companies in our area, so that we can that a best in class company is one that perform the process at the lowest cost with the highest degree of customer satisfaction or has the largest market share. Alright, so that we can make a comparison, right? We can adopt the way of the working, and then we can improvise, alright, from that benchmarking process. And then we also have the competitive benchmarking process, competitive performance benchmarking, where benchmarking is used to develop performance data needed to set functional expectation for new products. So if we don't have any set values to set the performance, our own performance, so where's the value come from? So it is important to have the benchmarking. So it involves testing a company's product against the best in class. So this is what we call as the competitive performance benchmarking. So these are the procedures involved in the competitive performance benchmarking procedure. First, determine the features, function, and any other factors, and then determine the features that are important to the technical success, and then until generate a benchmarking report summarizing all information learned about the product, data collected, and conclusions about the competitors. And then reverse engineering or product dissection, which means that we look into details on the product, right? We look into details on the product, which is as a snapshot of how other designers have combined parts to meet the customer needs, right? It is similar to benchmarking but narrower. Okay, so this product dissection or reverse engineering, it is much detailed compared to the benchmarking. Product dissection entails the dismantling of a product to determine the selection. Maybe if we need to, alright, maybe we need to buy the product from the competitor, and then we look at part by part on the product. For activities in product dissection process, discover the operational requirements of the product, examine how the product performs its function, determine the relationships between the component parts of the product, and also determine of the manufacturing and assembly processes. That's what we call as the learning process, because we want to learn something which is existing and we want to improve from that one. Okay. And then determining the engineering characteristics. Alright, like I mentioned in before, set of engineering characteristics consists of parameters, design variables, and constraints. The design team has begun to collect through the research, benchmarking, and also reverse engineering activities. Okay, so you can see here in this figure, alright, the product development of the hair dryer consists of some parameters, alright, that which is evolved a long time from 1922 until 2000. You can see, alright, the request is to dry a person's hair in the shortest duration, full safe condition without a second person to assist. Okay, so power to be engineered, which is some things that the team need to be working for, and airflow velocity need to be engineered. Heating temperature is fixed. Alright, this is the constraint lah. The constraint that we need to consider, maybe the type of material, the airflow velocity that cannot exceed, that cannot lead to the higher heating temperature, the power. Alright, you can see here in 1922 the types of blower is radial, heater, metallic, case used in this hair dryer. Moving to, and then this is the power. Alright, and then engineering design in 1950, moving to 1950, right? Still the same types of blower used, which is the radial, okay? And then the heater, metallic case with non-metallic holder. Maybe because due to the weight of the hair dryer, so they changed the non-metallic to the non-metallic material. So here is the power, alright? Market segment 1 that has different frequency. Alright, and then moving to the year 2000, change the type of blower to from radial to the axial using fully plastic case. Alright, which means that it is feasible to use the plastic case in the hair dryer as the times evolve. Alright, so I think I mentioned in one slide that how to connect these two items, customer relation requirements and engineering characteristics. Okay, so through this one of TQM tools, quality function deployment, QFD. So what is QFD? QFD is a planning and team problem-solving tool that has been adopted by a wide variety of companies as the tool of choice for focusing a design team's attention on satisfying customer needs throughout the product development process. Okay,